All right. So another topic that I want to talk about is the impact of a bounce on the amount of force um, delivered by by an object. All right. So I've got this snowman. Unfortunately, this snow person is being held at ballpoint. There's a rubber ball and there's a tennis ball. And the perpetrator decides to unload. Let's imagine that the rubber ball and the tennis ball are exactly the same mass and they're thrown with exactly the same speed. All right. So the amount of momentum that they have is completely 100% the same. Let's imagine, just to have some numbers, that combined total is an initial momentum of 10 kilogram meters per second. Now, the tennis ball is going to embed in our innocent snow stander right there. But the rubber ball is going to hit and it's going to bounce back, all right? Let's imagine it bounces back with exactly the same amount of speed, all of those things. And so it will, at the end, have a final momentum of 10 kilogram meters per second, but in the opposite direction. Let's think this through. In order for the tennis ball to stop, right? It's coming, it's coming, it's coming. It reaches the surface of the snowman. Once it reaches the surface, it starts receiving a force. That force is going to start changing its momentum, and it's going to go from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then it stops. But in order for the rubber ball to go from moving to moving the opposite direction, it's going to touch the surface of the snowman. It's going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, it's negative 10. So there's more momentum change on the bounce. Because instead of just going from 10 to 0, you're going from positive 10 through 0 down to negative 10. And because there's more of a momentum change, that means that it's a bigger impulse. The way that that's going to show up is either it took more time for the rubber ball to change direction and bounce back, or it took the same amount of time but more force. And likely, the middle ground is probably going to be somewhere in the middle. It's likely going to have taken more time to hit and change direction, but also have used a little bit more force, right? So instead of like maximizing this goes up by a little bit and the force goes up by a little bit. So the experience, I've never been in a riot crowd, but sometimes they use rubber bullets. The experience is that you actually have a bigger knockback being hit by a rubber bullet than you would by a skin penetrating round, right? The more you know.